Hello everyone, welcome to today's presentation. This video is about area under a curve by integration. Find the exact area bounded by the curve y is equal to x squared minus x minus 6, the y-axis, x-axis, and the line x is equal to 5. Now we need to take note that the exact area bounded by the curve is the area obtained by integration. Now we will begin by having a rough sketch of the area in question. Given that the coefficient of x squared in this function here is positive, the kind of graph that we'll expect is of that nature. Had it been negative, we would have had this. So we're going to consider a graph as such. So we'll have the Cartesian plane. Now, before we draw that, we also need to know the x-intercepts. So at the x-intercept, y is 0. So this equation will become x squared minus x minus 6 is equal to y, which is 0. Now solving this by factor method, we are going to look for two factors such that their product is equivalent to the product of coefficient of x squared, that is 1 times negative 6, which is negative 6, and the sum should be coefficient of x, the middle part, which is negative 1. Now the two factors are negative 3 and 2. So using these two factors here to split the middle part, we'll have x squared minus 3x plus 2x minus 6 is equal to 0. So in place of negative x, we've replaced with the negative 3x plus 2x. Now pairing and factorizing, we'll have this as x into x minus 3, and for the other part we have positive 2 into x minus 3 is equal to 0. So x minus 3 is common, and then in the brackets we'll have x plus 2 is equal to 0. So from here, this first bracket x minus 3 is equal to 0, and therefore x becomes positive 3. And for the other bracket, we also have x plus 2 is equal to 0, 2 crosses, so that we have x is equal to negative 2. So these are the x-intercepts. So coming to the graph, remember if we have this as x-axis and this as the y-axis, so we're just interested in the x-intercepts. Remember, we'd already determined that the nature of the curve is as shown. The coefficient of x squared is positive. So we'll have the first x-intercept on this side, negative 2, and the other one, this side, positive 3. And remember, the range has to go up to line x is equal to 5. So we have from negative 2, we'll have it as such. And then that leads us to line x is equal to 5. Remember, this begins from the y-axis. So the y-axis is line x is equal to 0. So if I may shade the region, we may begin it from here. So that means we are going to determine the area of this region and this region, and then we sum them up. So as you can see, this part here is on the lower part of the Cartesian plane, which is considered negative, and this other one is on the upper part, considered positive. So this should tell us that the results we'll get between 0 and 3 will be negative, but because it's area, we'll ignore the negative. The negative just shows the direction on the lower part, and then the upper part, we expect positive result. Well, now This already shows us the limits within which we'll be integrating. So in order to get the area bounded by the y-axis, the x-axis, and the curve, we will have to integrate from 0 to 3, that is x squared minus x minus 6, the equation of the curve, with respect to x. And then we also do the same for the limits 3 to 5. That is from 3 to 5, we have x squared minus x minus 6, again with respect to x. Now for this first part, we will have, so integrating, we have to add 1 to the power and divide by that power. So we have x power 3, that is 2 plus 1, and then divide by the same power 3. The same applies here, minus x power 2 over 2, and then here minus 6x plus c. Now this will be within the limits 0 to 3. And then for the other part, we'll have the same thing, but now the limit's different. We have x cubed over 3 minus x squared over 2 minus 6x plus a constant c. But now x ranging from 3 to 5. Now we are going to work out the first bracket by substituting for 3 in the expression, and then 0, and then we get the difference. So we are going to have the first bracket. When we substitute 3, we have 3 cubed over 3 minus 3 squared over 2 minus 6 into 3. Now for this case, we can even ignore c because in the end it will disappear. And then we'll have to subtract. So for the second bracket, we have 0 substituted. That means each and every term will go. So we'll have 0. And then for the next, we'll have, so we add to this. So for the first bracket, we substitute 5. So that means we have 5 cubed over 3 minus 5 squared over 2 minus 6 into 5. We can ignore c. And then subtract. Now next we are going to substitute for 3. We have 3 cubed over 3 minus 3 squared over 2 minus 6 into 3. Working out this from my calculator for this first bracket, I'm able to get negative 13.5. And then for this other bracket, I'm able to get 12 and 2/3. Remember, we had said earlier on that the negative here just shows the direction. It's on the lower part of the Cartesian plane. And because it's area, we'll just ignore the negative and add positive 13.5 to 12 and 2/3. Now this should give us 26 and a sixth square units. Now with this, we come to the end of the solution to this problem. Thank you for watching. Bye.